Hello everybody, welcome to another stream. How you doing? So I just logged in and I don't know how, but I've got 7,000 exactly followers. Apparently 1,000 people followed me recently. Need 2,000 actually. I have no idea what's going on. But anyway, welcome new people if it's real. How's it going? Last stream, what do we do? We was trying to get top level BVH to be rendered, and it now renders. I actually did a little bit of work off stream, which I'll quickly recap, so we understand where the problem was. Get my audios correct, there we go. So yeah, so basically here's the ellipsoid is in 0, 0, 0, and this is the camera rotating around that ellipsoid when it gets rendered. So yeah, we render it. Yeah, that's just in the local space of the object, how the cameras are relative to it. So this is the rotating object. We've got some clear problems. Obviously the Z ordering is a bit weird. And also I think the way that the rays get reflected are wrong. So as you can tell, this light stays still. This white one, if you look at that ball, it stays still, but in this one, I think it moves. It should stay purely on this side of the sphere and grow and shrink. So yeah, there's stuff to fix there, but that's what we're going to be looking at today. I quickly recap on how I got this rendering and what was our problem. So basically we combined, so this should have worked actually, I think, but I'm a bit, where is it? It's instance, isn't it? Wait a minute, there we go. Right, so I used to combine, yeah, okay, so I'll just tell you where we've ended up, and yeah, there might be a bug somewhere else in the code, or maybe my previous implementation, but basically what I changed it to. So I used to always want to do it in view space, but now I do it in world space, but the position is in view space, if you will. So we just basically subtract the translation from the world space position and get the view space position instead, and we use that. The reason is because I want to just get Milton out. So we've got like a box that we can render. So there's a box in 3D space. I'm trying to get enough room here to move my mouse. So there's a box in 3D space, and say our camera's like, yeah, our camera might be in the middle actually, because I want to do like reflections and stuff. Maybe we might not need the behind the camera. But anyway, imagine it's here for now. And we can view like this is our viewing angle. We, in our BVH, all of our objects that we're rendering, they're made out of ellipsoids, right? Are stored. All the ones that fit inside this box are in the BVH tree. So we can shoot rays at them and test if we got hits. So even if they're outside the view, we can still do it. So over here on the right hand side, that's 1. Over on the left hand side, that's -1. So in the BVH, in the top level BVH, -1 to 1 across all 3 dimensions. So it's signed, normalized values. So basically I want the camera to be in the middle at 0, 0, 0. So we're still going to be in world space in a sense. Like I was doing it in view space, but it was a little bit broken. So we're doing it in world space again, but we're centering it around the camera still. So the rotation is still going to be in world space. Something I could probably fix later on. But this, but when you hit one of these objects with a ray, maybe we do bouncing and, you know, reflections and stuff. So maybe you hit this. Oh, this will be in the future as well. It's not now. But say if you hit this object, you'll then go into its bottom level BVH and traverse this, and in local space, -1 to 1 again, right? Across all of the axes X, Y, Z. So we'll then transform our ray into the local space of the object. So the ray origin would be here, which would be technically outside of -1 to 1, but that's fine for the rate. And the ray direction will be going like that. Right. Wait. Is the ray going like that, wouldn't it? Yeah. Sorry, so the direction would be in the local space of the object. Yep. So I think in this case, there's no rotation that's been applied or scaling to this object since it is aligned to the world. So this will not even transform, or it won't transform around, but it could do. Yeah, so that's that explanation. Hey, Naaman. I forget to pronounce your name. Welcome back. How you been? How's it going? Apparently I've got 7,000 followers now. I don't know where they all came from. Seems like a bot thing to me. I let 2,000 people follow me. Weird. Is that true? Can you see that 7,000 number as well? But yeah, I'm doing good. It's been very busy today at work. Doing lots of things, juggling many things. But yeah, things are going well. Things are going very well. How about you? So basically what we do, so we used to like do a matrix multiply here every time we make an instance of a BVH. And you know, to get the center position, and then we matrix multiplied the half dims to get it into view space. And then we multiplied the quaternion to get into view space as well. But that method didn't work for some reason. So what we decided to do is just transform the world space component, or the world space center position into view space, and then just or just center it at least. Is that even right? Yeah, well from view, yeah. Yeah, center the yeah. Maybe that would be a bit wrong in the future, but I can correct it. Center the view space thing, and then so our instance data is always in world space instead. So now at the start of the shader, we will go back to how we used to do it, where at the start of the ray tracer, we take our view space ray direction when we shoot through each pixel, and then just make this sort of move the ray direction into world space with a matrix multiply. And then yes, so that means when we ray trace against our ellipsoids now, we're doing a sort of a world space to local space. thing. Okay, yeah, we're going from world space to local space and then doing the reverse ellipsoid in the local space of the ellipsoid. So now the next thing we want to do is unpick. Well, no, I want to fix the problem. The ray hits. As you can tell, the directions are wrong. This light that you're seeing here doesn't move, but when you look at this when it's rotating, it is moving. So I want to fix that first, and then we'll fix the Z. Maybe we'll fix the Z ordering at the same time. So let's take a look at that. So basically when you hit the object, we do it here, I guess. So we are ray tracing through the top level, but I've disabled the top level leaves and just made them all bottom level leaves and just done shading on them for now. And then we'll be ray tracing into the bottom level acceleration or BVHs in a minute. So basically, when it didn't translate it back properly, I don't think. So let's have a look at this. So when we take the ray direction, we just multiply it by the quaternion. Yes. So we multiply by the inverse of that quaternion. Hit position. This is missing an offset, isn't it? Oh, this is a position and not a... You only need to add that center position norm. Right, here's the problem. We need to add... So rotate hit position. And then we add the center position to it. I think that was wrong. Then I'll get it in world space. And then but really that'll be in local space when we enable top levels. So I'll write it for that so it's correct. Well no, yeah. The normal just needs a bit of rotation. Yeah. So we'll need to do another translation, I think, afterwards. But we'll do that when we enable this support. Yeah, then to get it in the hits T, so along the rate, we just need to just subtract from ray origin and do a length. Yep. Right, so I think that's the correction. So the lighting should now be correct, right? If this is our closest, it's our closest in world space. But yeah, we'll correct that. Then do some shading. Yeah, we'll change this back to world space in a sec. Well, you know what, let's hit T is always gonna be in world space. We need to move this into world space as well, and the hit normal. So hit normal local space. Then we need to actually move it into world space. So it will be, that's only when we enable the top level stuff. Because right now we're just treating the top levels as bottom levels. So hit pause local space. Hit normal local space. So these will be the world space versions. And voila. Ray origin. Have we got ray origin world space, have we? Well, I'll call it a view world space at the moment, isn't it? Right, that's be 0. So just be the length of that. Yeah. So something like this. So we'll fill in these 2 lines in just a bit. Let's just get these things working. Right, let's compile that and see what happens. Oh, hit normal. View world space, as we call it. Horrible name. Okay, so how much better is that? I don't know. Maybe we should draw the normal where we point the... It does look wrong. Because that looks like it's going that way. I don't know though. Hey, Musco. Transform's going okay. I've made up a new thing called view world space at the moment. It's incredibly wrong. But yeah, I'm not bothering going back to the old one because this one works. But yeah, when I looked back at my code again, after learning what the problem was, I convinced myself that it was correct before, but it didn't work. So I don't know. I don't actually know where I was going wrong. So I've just left this version in for now. Plus this one does one less, it always has less matrix multipliers anyway. So basically I'm in world space, but it's centered around the view position. That's the way I've decided to do it at the moment. Rather than doing in view space, because yeah. But yeah, it's going alright. Just trying to fix up some of these normals now. So I get the reflections looking okay when I rotate the object. We could draw it. Say if the mouse is here, draw the maybe the problem is, where do I draw it? Because well, yeah, we can do it. So if is mouse at E chord, but yeah, how's things with Eurus must go? Even not too much. So I think we can maybe get some kind of like position. Do we want to draw this from? So I think that is we've got to add some kind of world from view. So we've got to go GFX global world from view dot translation, and then we've got to add like that hit position view world space, and that's in world space. And then, well, probably could have just done the view space one, to be honest, but anyway, draw 3D vector in world space, position, the vector is hit normal, and yeah, bit of thickness. One's way too much in world space, I can tell you that. And then bit of color. I should have added a scale one to this because I do this so many times when I'm drawing vectors. As I do a moles and then a, I don't know, 2 or something. Just scale it up a bit. So now I should be able to see the vector when we put a mouse over it. I've been solving jigsaw puzzles with computer vision. Ooh. Oh, it seems to be working. Nah, it isn't working, is it? It's way too big. So you've been scanning puzzles in a computer and trying to... What? I don't understand. Looking at stuff made here and Mark Robert's puzzle solver robots, and I'm thinking, I can do this better. Okay. So... Wait, is it a thing on the computer? Or like... Why ain't this thing normalized? Oh, I've got to renormalize my things. Maybe. I am confused. Now normal looks well alright. Oh, for crying out loud. Yeah, so obviously if you put your normal here, look at the way it's pointing to the right, didn't it? Then if you hover this one, as it's rotating around, yeah, that looks okay, doesn't it? Whee! The power of debug shapes. So why then does that light? I guess the light is maybe a bit up in the sky, isn't it? Yeah, it might be kind of straight up in a way. Well, yeah, so I think that's okay. Right, so we did end up correcting them. I just thought it would have looked a bit different than this. Cool, so now what fixed what the Z firing's been odd. Is that? No, that's fine now, isn't it? Did that fix it in one go? Yes, that goes inside that one. Yeah. Nice. Right, so I think we're ready now to unpick the debug code because these are actually top level BVHs. So we're going to go ahead and... So if we remove this, well, we'll keep this in here actually, this is going to be very useful. So we're going to go ahead and do this and then remove this. So now we should be hitting those top levels and actually going inside and ray tracing against the... My worry is how am I going to get the how am I going to get the world space ones from here now? I need to retain I need to retain the quaternion, the scale, and the the quaternion, the scale, and the offset, isn't it? Alright, so have a look at that. It's a classic thing. You see someone else do that, you're like, oh, that's the thing I can do. Or yeah, or I can do that better. So Sorry, that guy's voice was annoying. So I turned it off. So is he using a robot? This is how my Gen Z brain works. Just skip through videos till I get the gist of it. Right, so okay, so you got a puzzle and it's mapping it out. All the puzzle pieces, maps them all out, and it's able to pick them up and then solve the puzzle. Crazy. Yeah, it's quite a... Yeah, I guess I get an idea of how you could start with that. Yeah, I think... Yeah, so you've got to obviously scan the image, scan the puzzle pieces, figure out which ones fit with each other, and that's going to be like an n kind of squared and a bit algorithm. I don't know how you what you put it in, to be honest, because they could have 4 sides each, isn't it, or something? And then you've got to then somehow shuffle them around and remove the robot arm and fit them together. It's probably a very basic way of doing it. White puzzles. There's only they only solve white puzzles. Mine will solve puzzles with or without pictures on them. Yeah, because you want it to solve like the with the method that I suggested. You want it to solve the puzzle. Ah, yeah, because no two puzzle pieces can stick together in a puzzle. You can get so much kind of do due to bad printing, but they don't fit nice and snug. So yeah, you want it to solve based on the edges, isn't it? And then I can do any of them. You just need a high enough resolution camera, right? White puzzles are easier to segment into puzzle pieces and background. Right. Okay. Yeah, because right, the corners. Yeah, when you take the photo or the images, yeah, scanning the edges might be harder. So you get to do a bit of edge detection. Amazing. So let's I need to store some memory. I need to store these buggers. So every time you hit, you actually need to take a backup of these guys. So I can translate. Nah. Yeah, I guess we'll do it. We'll do it for now because we can always optimize it. So we'll call this like uh bottom level center pause in world space. Right. Bottom level. Half dim or scale. Technically it's kind of like a scale. World space. And then the final one is the rotation. So this would be the world from local. Sorry, I want to say rotation. So that'd be a quad. So I'm going to fill these boys and girls in. So before we change anything... Oh wait, we would have changed it. No, we wouldn't. I'll get it there. What's the key? Oh, is that key? Okay. Whoops. Press the wrong key. That key. Where is that key? Cool, cool, cool. So, yeah, let's get rid of that and then... Oh. So, I want center pos norm. So this be half dims. How much to scale it by. And then some rotation, space from local rotation. Right, so now with these, we can actually, when we hit an ellipsoid, we'll be able to take it from local space into that view world space thing, which is a weird thing that I've just made up. So the position is in view space, but everything else is in world space. So so we need to do a few things, right? We need to first translate. So yeah, translate scale. Sorry, rotate and scale first, and then you translate the end. So I guess we'll just do it all in one line. So it'd be bomb level, wad from local rotation. So you apply the rotation, then you apply some form of scaling. So we're going to multiply by the half dims. I think it might be a little bit off actually, I've got to play with that. So this is just a mole, and then we do an add. The final position thing on the end. So that'll just be something like BL. I messed it up already. Center position, wall space. Right, I messed this one up. This is BL scale. Right. So the normal, you just need, or you need, yeah, you need to actually do this many. And the reason why it was kind of funny, right, so because it's a scale, you just want to copy the sign, isn't it? You just want to do a copy sign. So if you get to, now you multiply with a sign. Yep. Do we have one of those functions for that? So we multiply with sign like that, yeah. So we get minus 1 or 1. Yeah, so we basically want that, but for oh, I was hoping to be right. So I want to yoink that. Oh. Oh. Right, what am I doing? Yank. And then I want to paste over that. Oh, okay. Hit normal. Right, so you apply, you do the rotation, into world space from the local space of the object, and then you multiply with the scale to get, yeah. So maybe we could pack that down if we are storing it into like just a few bits. Because we only need the sign information. What else? What's going on? So, no scaling there or anything. Cool, I think that's everything. So, should we plug this? Yeah, it's all plugged in now. Let's see how it looks. So we should be ray tracing against 2 instances and going inside them as well. Right, they look... incredibly wrong, mind you. So something is definitely wrong with the ray. Is that right? Yeah, they're definitely stretched. Yeah, something's wrong with the ray. Although, like, if I look at this one that's not got the rotation, besides the ellipsoid cutout that it's got, it's basically okay. Proportionally. What is horribly wrong is the coloring. I can understand why the coloring looks so damn funky. We could just use the, we've got that debug thing going on. We can get in there. Right. I'm hovering over here. I'm not seeing any. Right, so as you can tell, I'm hovering there. And in views, in world space, is putting, there's a little arrow that shows up. You see those arrows that are showing up? They're meant to be on the objects themselves. So clearly, you see those arrows, they're just really wrong. So they're very much off the... Right, that one's a weird one. Alright, so move into local space. From the ellipsoid into local space of the whole object. Translate, yep. See, I wonder if we need to normalize these normals. Maybe. It could be part of the problem. Maybe you don't need to. So I think this line's a bit wrong. But yeah, this line is a bit wrong, but this result ends up being wrong because that's what we're drawing. Oh, wait. Yeah. Yeah, that's fine. So, ray origin. At that point in time, ray origin would have been translated. So this is actually going to be ray... in that view world space thing, which will probably just be 0. But that's okay. Right, so now things are looking a bit different. They still a bit strange. And yeah, when I put these over, they're still kind of in very similar places. Didn't change this, or they're in the same sort of place because we've not changed that hip position code. The hip position code is very much incorrect. Oh, we shouldn't multiply sine on the scale. We should, yeah, we shouldn't multiply the sine of scale for position, but for the normal we do that. But that's not going to be the fix, surely. Right. Oh, that's kind of fixed it, I think. Just the colors are way off. Don't know what I've been doing, but is it though? So the problem is, as you can tell, I'm actually hitting a ton of spheres when I look here, because look at that. It's rendering. Well, something weird's going on. But yeah, so we'll keep this code around, obviously, because we should only be seeing one normal, probably. Like one. There we go. So you see one, B, hit the overlap, and you see two. Yeah, we don't early out through the BVH yet, by the looks of it, so it's slow. But yeah, so we're going around the sphere. That looks all right. You know, if I find one here, it's hard to tell with this one. But yeah, so what is wrong, right? What is now wrong? Because the ellipsoid was rendering fine. The color was fine before we did any of this top level. When we had top level leaf, then we traversed into the bottom level. Before we did any of this, it was all okay. So the ray direction is wrong. What we want is the ray direction in the world space. That might be it. That might be all that we're missing. And if so, that is good. Well, hey, there we go. Now we're getting our lovely soft tile. It's still got that ellipsoid edge around it though. We can look into that. And when you scale this one, it's been scaled a little bit funny, not gonna lie. No, maybe that's okay. Hard to tell. Yeah, it's a little bit wrong. Oh. So when it's, yeah, that's how you expect it to be when it's at there, basically. When it's, because it's meant to be stretched along the X. So I guess let's look into this outer clipping. Like that's coming from the fact we've got these ellipsoids parents, and it's obviously not big enough. So one problem is that this tile one exceeds the signed norm boundary of -1 to 1. So I guess we'll fix that first. So we just go into when we code gen it, we generate it all in code. So model tile, here's the code. We just generate a bunch of ellipsoids in a grid. So I think we didn't do it. Center position. Right. So it does offset by half dim. Half dim times by 1.5. What's that all about? Oh, right. So the X and Z. Why is it scaling by 1.5? Oh yes, it makes them a little bit bigger. So they look. So instead of times it by 1.5, instead we should squish this by 0.5. Just squish the Y, then it wouldn't make the X and Z axes exceed the -1 to 1 range of the space that you have when you build models. So now what do we have? So they look squished. Look a bunch of pebbles now. Another thing we could do is just get rid of the outer edge, but we've still got the issue where it's not quite big enough. Now, so the other thing is that you have, like why is that? I think it's when we build the tree, that is pack. So when we pack the quad tree, we traverse from the bottom of the tree and go up. And when we reach almost at a leaf node, we take the build instance and we construct a, from the half dims, we construct a, see, I was thinking this should probably be known as scale or something. And then to get the scale, we just divide by square root of 3. Like the naming is a little bit silly. Because half dims, this would be like, it's kind of like an axis line bounding box, and then we're timesing it by that. Yeah, I think we need to get the square root of 3 and then divide. So when we build the tree, we're making sure that the ellipsoid is we're making sure the ellipsoid, so initially the scale is like a box, just scaling a box up. Because it's ellipsoid, it needs to be multiplied by square root of 3 to fit all the edges of the box in. But I think when we ray trace against it, there's a problem where, so if you take those half dims of that ellipsoid and then we divide so we'll be dividing the ray origin by that. So would that be squishing it less or squishing it more? Right, let's just try the square root of 3 thing for a sec. Because it'd just be easier just to test it. So if we divide these further division, that will get us back to how big it is as a box, how much it was scaled up by. So the scale is, and then down here the scale. Okay. So let's try that out and see if that improves it. What the crap's going on here? That should be an S. Right, we're not seeing any cutouts anymore. Excellent. So on its own objects, we're not seeing any cutouts, which is super cool. The shape that surrounds it is a lot bigger, but obviously when we see it intersect these two, we are seeing that there is, you know, hitting this top, this bottom level BVH, for some reason stops us hitting these guys behind, for some reason. But if we go this way around, still the same problem. I don't know why that is, so we need to fix that now. And then we need to fix that rotation looking a bit weird. Alright, so what would be the next problemo? So the next thing is, so are we not restoring something? Are we not restoring these and going? Because we basically want to know if we hit two of the. So I've got my is mouse at, right? Have I got this elsewhere? Because we can just do printing, right? Right, so I'm not using it anywhere else. So if it is mouse at, but instead here, right? And we'll print out GPU hprintf hit bottom level BVH, and we'll encode some kind of, I don't know, is there a node index dot about? Child index, no. So there we go. So we should see two of those ideally, but I don't think we will. So I've also got a bunch of stuff being printed out. We don't really need that anymore. So let's remove that. So how many of these do we see? They should be the same every frame as well. So when I hover here, oh, they're not the same every frame. How amazing. Right, of course, because they get allocated differently. Right, hold on a minute. If we remove this base index, they will be the same. So it'll be relative from within the tree. The tree will stay the same, but the allocation within the big old buffer will be different. Okay, so here we've hit BVH 0, here we've hit BVH 1. But we can never hit both of them. So I guess that's kind of obvious, right? Based on what we're seeing here. We're never hitting both, which is bizarre. So, why? Oh, I know why. This one takes over. Oh, for crying out loud. KDE. Right, my laptop's locked out for 5 minutes. Because apparently I tried my password 5 times, but I didn't. Okay, so we are instantly changing the ray position and stuff. Right? That's a bit bizarre, isn't it? Right, I did not see this problem when I wrote the code. So as soon as we hit top level leaf, we're like, hold your horses. And we don't. What's this damn shame? It's this traversal algorithm. So the way the traversal algorithm works, let's describe that. So here's a tree. We start at the root children. We check the first root child. Have we hit it? Yes. We pop a pointer to the array of up to 4 children because all 4 children sit next to each other in memory. So we put a pointer to the first one and say how many children in it. We put that onto a stack somewhere. Then we check its sibling, which is next to it in memory. Check that. Have we hit this one? Yes, we have. Now we put a pointer to this one, and it's got 4 children on the stack as well. Right, and then we pop off the top of the stack, and then we check this one. Do the same thing. Have we hit this one? Yes. Check this one. Have we hit it? Yes, and so on. Just repeat. Right. Now, when you hit these leaves, it's a bit of a different thing. The problem with the leaves is that I can't. The problem with the leaf nodes is that if it's a top level leaf, which links to a bottom level BVH, which is another whole BVH, we're just going to swap out straight to that one. It's kind of different from the algorithm, how it works. So rather than going across all the siblings first, it just goes to its one. One, it just swaps it out. So I'm thinking like, do we change the algorithm such that we just keep going down the tree and then coming up when we've keep going down the tree first. Like this sort of algorithm. Or do we find a way to store so when we hit top level leaf node and start doing a bottom level, do we find a way to know, hey, this node item is actually an instance? So you need to pull out all the data again. Yeah, I might change the traversal algorithm. So in the stack, I want it to be 16-bit integers. They're 32-bit ints for now. But we could technically keep it 32 bits, and then in the high bits, store the BVH ref. Then if the BVH ref differs, we simply swap out. We recompute we do all this sort of stuff. We change the ray origin, and we you, 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 know. change the base node index. Wait, but you don't need to change the base node index if you stick it in the stack anywhere in the high bits. You can just but yeah, then if it differs, you set up these sorts of things. That could work. But the issue is like will you be sitting on the top of the stack? Yeah, I think this can still work. I still like this method. The only problem is I'm wasting. I was hoping to reduce my number of VGPRs. So instead, I'm not going to be able to reduce my VGPRs by packing into 16 bytes. But this can work for now. So we'll just take a U32 on the node stack. So we'll have the we'll have a node ref in the low bits, right? So this would be a BVH ref (16) ORed with node ref, right? So that's basically the data structure. I'm not gonna bother making anything specifically for it because it's just used here. So what do we do here, right? Well, we put BC BVH ref shift left 16 or with that, yeah. Damn, my damn laptop. I'm gonna have to restart that thing. It's so bloody annoying. I think I need to update it. Sometimes when it locks, it just goes into... It locks me out completely. Yeah, did it? Never checked that. Yeah, it's wrapped in brackets. That's all good. Hey, Freddy Gamer, how's it going? I'm Software 2. Cool. Welcome, sir. How you been? How are you? Right, so I think that can work. So we just gotta... And we've got to keep running another damn register. So we'll keep around like, hey, what is the current BVH ref? So we can then say, hey, if it's different, yeah, but the problem is if it's different, how am I going to get this information? Like I've just lost it. This is the instance data. So maybe instead of storing a BVH ref in there, you store an instance index, which means you've got to get it from right, let's get the chat back up on my laptop. So if we store an instance index, we'll be able to fetch the node back. So you'll know the parent. But do you need the BVH ref in any way? You just need the node. If you need to know the base. Yeah, but you get the BVH ref from that node anyway, yeah. That means I have to extract the data again. Right, I think my chat's come back on my laptop. Damn it. Cool, there we go, we're back. Yeah, we'll just do that. So we're not, okay, so actually we're storing a 16-bit indices. Instance. Yes, it's in the instance node index. It's horrible, but yeah, it's stored in there. That'll work for now. So that would just be, in this case, we'll put all bits on. That'll be the invalid value. Cool. All bits on. Then, so when we hit top level leaf, all we're going to do is restart the stack. Sorry, we're going to push on, push onto the stack. And we'll push on the node index, like the full-on one. So it'll be like a children or child node start index plus child index. Shifted left by 16, then ORed with that. And I think that yeah, we can get the base index again. So put that on the stack, and then all of this is a result of like, well, if the instance thing has changed, you need to update all of this again. So that would be here, where you say if the instance node index is not equal to I guess we'll call it the parent instance node index. Whatever. Then that'll just go in here. And we've got to correct it all. Okay, so I think we're doing okay. So what should it be called? We need to keep. Alright, base node index is already there in it, so I can go. So we can call this like, so at this point this would be like, what is the parent instance for this node? There'll be node stack index shift right by 16. These will be ANDed by 16 bits. Yeah, so we need another U32 instance node index. So by default, all bits on. Right, so now if it's changed, we definitely need to make sure that we set it. We definitely need to make sure that we set this doesn't change every time. Then we need to fetch the node. So the node is whatever this is. So it's the base node index of the BVH, the top level BVH. Then it's this instance node index which goes there. So that will get you your node. You can then get the BVH ref from there, unpack that. You can then unpack all of the lovely stuff here. Yes, you can unpack the BVH ref, all of the transform information. You then take the ray, right nearly there. There'll be, right. So it'll be ray origin. Hey Sully, you're playing the FromSoft games? We mean like you mean like Dark Souls and stuff? What is this game? So we're currently building the rendering technology for a game. I've not really gone over my plans for the game idea, but I've got the game idea all written up. So we're currently implementing the rendering technology first, which is basically rendering ellipsoids. We've got like PBR. So here's some ellipsoids and things. We're currently just trying to get instances, so we build models out of these ellipsoids. Don't know why this got a bit teary. What's happening there? Maybe that was due to a glitch. Oh yeah, that was due to when I was taking many of the same photo. Right. And was fixing the screenshot tool. Yeah. But yeah, it's gonna be an RPG that people know. And Kingsfield, Bloodborne. No, I've already played those games. They're too difficult for me. I just get so enraged. And it makes me want to just put the controller down. I don't like throw my controllers because I don't want to ruin them. But yeah, it just makes me want to put the controller down and walk away. Really angry. I tried playing Dark Souls 3. And I think Bloodborne as well. And people keep saying get Elden Ring. But I've not mustered my strength enough to buy it and try it. If some engine does it, other engines don't do. Sure, there's lots of little things. It's more simple and the code's easier to work with. It compiles within less than 2 seconds. It compiles all the shaders in a second and or less than a second in the code and a bit more than a second. There's more lightweight. There's probably, it's written in C as well, so it's not written in C++. So from a programmer's perspective, like working in it, obviously prefer much more. In terms of like front end for people, like features wise, I do all the rendering using compute shaders, but other engines have compute shaders. But yeah, so I'm not using a bunch of other rendering tech people typically use. That's a bit of a challenge. I'm trying to make it so there's going to be like a built-in editor within the game, but it's not like an editor where it's like an editor for like a general game. It's an editor that's built specifically for the game in mind. So there's going to be like, so the tooling, So it allowed me to build like models in there and animate them and things like this. And switch between it and hopefully work quite efficiently as well. But yeah. But yeah, I do like making engines too. That's my number one reason why I'm doing it, probably. Elden Ring is great. I've been playing Dark Souls 1 lately. It's a bit clunky. And the clunk is so real. Yeah. So when you go back and play like a PS2 game and you realize that how crazy some games were. They're just really hard to play. They're like puzzle games, like The Witness. Yeah, I guess I've played some. I've not really played The Witness, but I've played some puzzle games. They're not bad. Um, but the games I used to play a lot was like RPGs, um, lots of shooters, RTSs, a lot of RTSs. Um, yeah, basically the genres I used to play a lot. Oh, Metal Gear Solid. Played that too. That's a good one. Metal Gear Solid is a zero clunk. Yeah, because the gameplay is kind of rigid anyway with Metal Gear, right? It's not like kind of like platformery, is it? It's kind of like, yeah, you could a lot less physical things going on, I guess. It's good fun though, Metal Gear. Are you talking about clunk as in like not polished, or talking about clunk as in FPS? So extract these. Rotate the ray origin and ray direction. Change the base node index. So then that would mean as well, like if the new one instance node is equal to then we want to restore, finish traversing the bottom level BVH, restore the top level. I think that's it, isn't it? So how do you get this bottom level start thing? That can disappear. So when you hit oh, maybe we didn't set that value so it didn't get restored. Right, we've got to be careful as well. Where else would you set do we set the node stack? Right, when you hit bottom level leaf. No. Yeah, when you hit parent, we need to copy the instance. Instance node index ord over shift left to 16. So I think that's what we need. So that should do all the traversal now without any problems. Fingers crossed, eh? So yeah, if the stream dies, I'll be right back, but AMD drivers would have crashed me down. Right, so here we go. And we're still here and alive. And I think that's fixed the problem. Look at that. 2 instances without, when we put our mouse over here. Oh, I've removed the printing code. Okay, maybe not. Right. Oh, shoot, what's that? I saw a bit of a glitch. No, you bastard. Yeah, there it is. Right, that's to do with this object. Yeah. Because the scaling and the rotation is a bit wrong. Okay, it's a bit wrong. So we can correct that. Right, that's the next one on the agenda. The rotation is a bit off. It's super simple and well polished. Okay, yeah, clunky is poor polish. Things just feel crap. Too much friction between player interactions and how input is processed. Right. Yeah. So like when you but also sometimes with physics as well, like you walk near the edge of something, it just behaves weird. Lots of stuff like that too. I'm not using Helix for work yet. Just because I'm trying to be more productive at work, but I do want to move over to it eventually. I think there will be some issues I've got to solve because the work code base is many files. I can handle the files quite well at the moment in my code base. It might not be that much of a pain, but I might have to. Yeah, I might be okay. I might be okay. Because I got all the fuzzy find tools. It should be alright actually. But yeah, I've got to set up like the build system and stuff like that. So if I'm going to switch over to Helix, I'll probably do it in my own time. I'll turn on the work machine and get over the config and install it all in my own time because yeah, I don't use company time setting it up when I can just use Visual Studio. But yeah, look at that. Ugh, it's ugly. So what is wrong with my translation or my rotation? Why is it causing such funny business? So we can draw the outlines quite easily because past me has already done it here. So I could just nick this code and I can just go into the top level when we hit top level. So really, when we get to the optimization, you see how this if statement is very small. We want our if statements to be this small, kinda. It would be good. Because this is branchy code and we're trying to reduce the amount of branches we have. So doing all of this is crazy because this is a big old function in here that calculates surface color, does all the PBR and that. It's kind of nuts. Probably not helping with performance. But for now, we want to drop this in here. And I would like to render the outline. Yeah, I tried all the Vim distributions and that. Yeah, I tried those. Okay, so there's the Yeah, so as you can tell, the ellipsoids aren't the best kind of fitting things. I think maybe we can use a square root of 2 on this one, honestly. I think it might be okay. We can go back to it. Yeah, these are weird. No y. So let's take a look at like what it's doing. We'll follow it through from CP side. So we make the instance. Here it is. No, here it is here. So I've offset it a bit. There's 2 in world space. And then we've got 2 in the half dimensions, so it's 4. And then it's got a bit of rotation, which, you know, just rotates, right? So when we build the instance, we, you know, move the world space position into view space, and then we squish down the bounds such that they are from a range between -1 and 1. And then we keep the rotation in there and chuck it in there. Am I missing like a normalized? Can I like norm my quaternion a bit? Does that fix any issues? TJs, thanks so much for the raid, sir. Appreciate it. How you been? How's things going? You ever use CSS to configure NeoVim? I didn't know that was a thing. There wouldn't be CSS in NeoVim, surely. Welcome, Raiders. So we're currently working on a game without an engine, but we're kind of building the engine side of the game. Right now we're doing rendering. So we're trying to build a bunch of models out of ellipsoids. So we've just been ray tracing using compute shaders. And we're currently getting instances working. So you have instances of these different ellipsoid things that you make. So this is a tile, and there's another tile that's being rotated. It's been a bit weird. So yeah, we're just looking into what's going on really, and trying to figure out why this thing is kind of squishing when it rotates. It is kind of scaled along the x dimension by 2 times. But yeah, so we're hopefully going to finish up on this sort of stuff today. That's the aim. But yeah, how did stream go, TJ? Thank you, sir, for the raid. Let's catch up with the chats. TJ's doing it. I didn't realize you could do the CSSs in the NeoVim. Isn't that overkill? How does CSS make any sense for NeoVim? Strange, bizarre. Also supporting that. Yeah, you based Vulkan so long, I didn't touch my VK path tracer. How long have I been working on this? So it's been over a year now, in my spare time. Tuesday, Thursday, Sunday, after work. It's all written from scratch in C. I've got controller support, a custom UI. So I've got a texture viewer here, so we can take screenshots and analyze the screenshots. And got different tabs, so we can compare 2 screenshots. Different viewing modes for the textures, view different channels, view different stages in the renderer, things get written out. So here's the main surface. We can see like, oh, this is after we've ray traced, and this is when it's cleared, then ray traced, and we drill the UI. You know, this is different times in the frame when the resource was written to, and we can debug that. Here's the glyph cache, the texture glyph cache. So yeah, we can see like change the white black levels, help focus on certain information. So I've got a UI thing. I've got debug drawing, so can debug draw all these little things. Yeah. I'm looking at working on more of an editor soon, so we can build objects and things all in the engine. So yeah, that's what we've been working on. And I've also got a custom C compiler for shaders, which I wrote 2 years ago now, I think. I don't know, time goes. Yeah, I wrote this C compiler, so it compiles C to SPIR-V, so we can use it for shaders. So all the shaders are written in C as well, with some restrictions, obviously, like we don't have pointers and stuff. But it's really nice because we can share structures and functions between CPU and GPU. We can have multiple shaders in a single file. Tons of stuff, right? Because shader programming basically sucks, and I wanted to have a more of a joyful experience with that. So yeah, I'm super excited about that. Thank you so much. So yeah, I've rendered to a texture. Yeah, I've rendered to a texture right now. Is there AI in your work? Because otherwise it won't get popular. Well, eventually there'll be game AI. And it won't be with ML though, if that's what you're talking about. Also, you plan on rolling your NIM GUI for the editor. Well, I've already got it, right? I've already got my own immediate mode UI. This is it. It's in the engine already. So it's a game without an engine, but there's an engine folder. So UI, I've got OS abstraction, GPU abstraction, and core for all the memory allocation stuff and arrays and things. So yeah, it's there already. Yeah, shaders are kind of difficult. Like whole rendering, especially 3D rendering, it does take a bit to get used to, but eventually it becomes easier. But yeah, the whole GPU landscape is also way too complicated than it should be. But it is becoming easier with time, I guess. Yeah, it also sounds like, and I think there's another common one. Engine without game. That's another one that people troll me about. Yeah, but we'll get to the game part eventually. We're just building up a unique kind of rendering thing because I don't want to just do something traditional. I want to sort of just, try and build something a little bit unique, I run the game company Arrogant Pixel below. Nice to meet you. Nice to meet you too. Let me have a gander. Ah, I think I've seen this logo. Okay. I'm not sure if I've heard of these titles, not gonna lie. Maybe. Oh, alright. My game's running, so I can't actually click with a mouse. So whereabouts are you based? Oh, you got sequel, nice. What sort of genres? Yeah, that's cool. Niche games are where it's at these days anyway. Like, a lot of the time. Oh, you're London. Ah, fellow Londoner. From the UK, eh? Cool. Good to know. Yeah, I live in Kent. So southeast. I work for do 3D rendering there full time. That's my gig. So we got point and click adventure game from a few years ago, and an RTS they're working on for 4 years. Awesome. And a Boomer Shooter. I love Boomer Shooters. It's just such a great title. But yeah, amazing. That's cool, man. Do you roll your own technologies, or do you use like an engine and or things? Um, right. So it could be something to do with the scale. So right. So the scales in. Oh, we should have scaled then rotated. Is that right? Yeah, I think we've done our thing a bit wrong. Well, yeah, of course we've done it wrong. That's why we're investigating. Right. The words are coming out sometimes. So I think. Let's have a think about it. So. If we rotate. Yeah, I think the order of rotation and scale is wrong. Joys. They just love transforms. So we rotate last. So if we have the ellipsoid, or the model. What way are we doing it? So I do that. And that. What happens? Oh, it fixed it. I've got to do it in one more place. That's good, isn't it? Oh yeah. So now it's... So, I also want to play around with if I did a square root. Can use square root of 2 instead. And then that would reduce the size of these ellipsoids. Because it can get quite hairy. The scenes. That's the stretching. So can I use square root of 2? Quick Google. What people have done before Google, eh? I'm wondering. Maybe you square root of 2 instead. I tried the square root. Hang on a minute. Oh, you're back up. Tried it before, but it ended up being wrong sometimes. Let's take square root of 2 with us and fix that up in... square root. Right, so let's try square root of 2 here. When we construct the tree. Hopefully that works. Oh my days, what's going on here? Oh, I delete the square root of 3. For the other ones that need it. Alright, let's try that. There's unity for everything so far. Cool, cool. Fair play. Do you, Are your games like... Well, your previous two games were 2D, isn't it? 3D is your new one, I assume, the Boomer Shooter. But it's kind of like probably 2D still. Yeah, I think those fit a lot tighter, and they actually still fit. So I'm confused why I need a square root of 3 sometimes when I do more complicated things. Yeah, square root of 2 is tighter fit. It might be... Oh, it's with the corners, isn't it? Yeah, because if I was to build... If I were to build this up... Yeah, that's why. So this... Square root of 2 will get me... the edges of the ellipsoid where the normals are at 0, if you will, on one of the axes. But when you use to get all of them in a diagonal, it will go out of bounds, isn't it? Yeah. So we've got to use square root of 3. That's alright, I can improve that later. This ain't the main problem. Right, so get back that square root of 3. Yeah, point click 2D. The RTS is full 3D. Oh wow, cool. Nice one. Have you announced your RTS game yet? I'd like to take a look at that. I used to be a fan of RTS games a lot. I used to play them quite a bit. Mainly the more smaller RTS. Like I played Dawn of War a lot as a kid. And I played StarCraft. Yeah, good times. I'm personally kind of in the middle where I do stuff with existing engines, stuff on my own from scratch implementations, and stuff where I'm modding old console games, and because of that, I never complete anything. Yep. Don't worry, like sometimes you just do stuff because you want to learn and it's fun. And learning it itself is fun. You know, I haven't finished a game because I'm too busy just having fun. Either doing... I get to when we build a prototype of a game and I'm like, but I never really think this would be a really good full game. So I just go on to the next game idea. I have released my compiler. So that's something I've completed and released. And I guess since then, you know, I've designed this project and I think, you know what, maybe this one could be possible. It's definitely the one I still want to build. I want to have to, when I've built like the tooling around building models and get to doing the actual game part, I want to sit down and really think it through logistically, you know, how I'm going to actually achieve this thing. But yeah, a lot of time learning is just the fun part, and there's so much to learn in game dev. And so yeah, I wouldn't put it too hard on yourself when you never complete anything. Yeah, this thing I want to finish, obviously. And then I'll have an engine which is built specifically for this game, but I can take it and put it onto towards the next game. You know, changing probably tons of stuff, and maybe not changing, keeping things, changing things, building a new thing. Yes, called Territorial. Naviganda. Territorial. Someone's got your game name with an I. What did you say your... What was it again? Arrogant Pixel, that's it. I remember the pixel thing. Oh, you've got a video. No way, planet Earth disappears. Spoilers. Oh, you got the whole rock, paper, scissors mechanic. Oh, you're going all in and building stuff as well. Cool. So I still show them resay it. I did that exactly. I did exactly that too for years before I released the first game. It takes so much discipline to stay on one idea. Yep, that's for sure. You really got to like the idea and want to do it. That's the problem. And like, also you got to believe like this idea is actually going to work. That's cool. Very nice. How big's your team working on? Working on your project? You're like what? Hang on a minute. I'm already forgetting. My brain right now is just like. Whoop. Yeah, you got the RTS and the boom shooter. Yeah. So how many folks roughly? You don't have to give me exact numbers. 8. Cool. Yeah. See, it's interesting how like I always find this really interesting about small teams. Like small teams take a lot more risk, and they also do a lot more because there's less overhead with everything that comes from having teams of people. Um, so be it smaller teams make their own technologies. It's just really weird technology sometimes. Like they got a very specific problem and they solve it. And a big company wouldn't even do that. Wouldn't dream of doing that. Um, so and yeah, multiple games. You know, work on multiple games at once. Um, yeah, all sorts of things. So I do. You know, I'm really interested by the small team dynamic. Because yeah, definitely a lot more riskier though. Well, I guess there's always risk in the games industry. Whatever the team size is, just a different kind of risk. Right, I'm happy with where this is going. Oh yeah, we've got to fix the normals, the scaling and the whatever's the wrong way around on the normals, I think. So we went position, rotation, scale. When we go in sort of like from world to local space. So when we're going from local to world space, we need to go scale, rotation, translation. So when we do a lovely hit, which is here, so there's no scale here. So scale needs to go first. Let's just swap these around. Right, so scale the position, rotate the position, then we add the offset to get into world space. Now, hit normal. I guess we'll follow suit. But it's just multiplying with a sine of that, but yeah. Rightio. I think that's what we want. So, nearly there now, I think. Shall we do a bit of performance testing and see how terrible this is? Yeah, so getting the scaling in there. That's really cool. We can stretch it. We could have a bit of fun, right? Let's animate the stretch. So we've got this thing called angle which goes around. Well, if we just use that angle variable and here just do like a sine of angle multiplied by 0.5 plus 0.5 to make it 0 to 1. So from -1 to 1 to 0 to 1. And then we can multiply that by 5 or something, right? And then we can see that animate as it rotates around. When we started, it was just you. Yeah, I can imagine. Well, that's really good. It's very impressive you managed to make your own business and things. One day I might be that ambitious from this project. I don't know. We'll see. I like when these things squish down to 0. We get a nice glitch. But yeah, so we're getting some stretching, and that's cool. So we can scale models and things. So let's look at performance. You know, what's the key takeaway from performance, or what I want from the performance? I want it to be good enough so I can build a scene. I don't want it to be hyper optimized. That comes later, but at least something where it's manageable to build something. So we're going to be putting a bunch of instances out, but let's just see what it's like with 2 instances with a bit of stretching. So the BVH ray tracer is about 1.6 ms right now. These are kind of like, when you do it kind of full screen, just going through 2 of them, it can get around like probably at 4, maybe 5 milliseconds at times. So there's kind of like a few things to do. We're doing a bunch of shading in some of the inside the loop. We're kind of early and out of the first pixel, but we've not got. There's also other things like, if we come over to this example, if I hover my mouse here, can you see how we get 2 arrows? That's because if that single pixel hits 2 of the objects, that one hits 3 of them. So I think, oh, maybe that's okay. Yeah, but basically we've got to not traverse down the tree if we've already gone, like, let me get out Milton here. So basically, right, you got your camera, you hit this object, right? You got another object behind it. Then you decide to ray trace against this guy. Maybe this guy has a bunch of objects inside it as well because it's an instanced object, right? When you hit this object behind and do a test, you've already hit this one and found a closer hit. So we don't want to go into here, then ray trace all of these things, right? So we want to make that. I think I've not done that. So that should give us some speed up. Well, I didn't think it would give us any speed up for what we have right now. But we can, well, let's see when we overlap the 2 things. So we can do that. This, to this angle here, is about 3 ms, kinda big. You can see if I put the mouse down, yeah, if I put the mouse down, you can see it's doing it. The normals that it's calculating, like it's already hit these ones at the front, maybe. I don't know. See, if we did it in view space, that's another optimization we could do. If it's in view space, we could get it to pick the closest hit and traverse down there. Yeah. Well, you could already get the, if you do the length operation, you just do a square of the squared length. You could do a comparison, it could be quite cheap. You don't need it. Yes, another thing you could do is you could pick the closest one of the four. So when you take your... I wonder how you do that. Because we just pop it on the node stack. I guess you could get the node stack and reorder it up to 4 elements or something. And then traverse down the closest one. But it could be... I wonder if what the trade-off would be like. See, if it's a binary tree, it would be easier. You just... We got 4 children, unfortunately. If it's a binary tree, you just check two values and go with that one. But yeah, that's all right. So that's not an optimization we'll do today, but there's something to think about. Maybe we do go the binary tree route again, go back to that. Okay, so the optimization I wanted to make was, hey, we've already hit so the problem is you've got to get your hit back. Your hit's going to be in you'll be in the local space of the object as you're traversing down. So if you transition your closest hit down into local space as well. So what is the... Yeah, so one thing... Closest hit depth. In this view world space thing that I'm doing, it's very dumb. Where the position's in view space, but everything else in world space. Anyway, silly things I do. Right, so I'm thinking like, when we transition and do this, we can have our hit in closest hit depth, and that'll be in the current space that you're in, whatever it is, whatever that current space is. So whenever you traverse down yes, you restore this one. So yeah, you restore that when you come out of the bottom level BVH. Where's the music gone? Then we need to restore, we need to create it by taking the hit depth. So do we just recompute it? Yeah, you would probably go across the ray. Oh wait, no. Yeah, so this scale involved, isn't it? So kind of you've got to recompute it. So you basically do, you get your vector, and then you I guess you rotate and scale the vector, and then take a length op on it. Rotate and scale, take a length op. So you've got ray direction, right? We do the rotation. we do the rotation here, then we scale it by this inverse dims or whatever. So if I were to project it across there, then apply the same thing, and then redo a length op on it. So here we guess we get a bit of reuse. So you do like a closest hit vector. So that would be mol s ray direction with the closest hit depth. Right. Then you apply the same sort of scale. Wait, so another thing with the direction. Why do we multiply? Yeah, so we're scaling the direction, which is a normal. That's going to mess up things. That ain't good. We'll look into that. But yeah, let's quickly write the rest of this code out. I wrote that first one wrong. Right, so you scale that back, then you take the length op on that. Yeah, so you do the length on that vector, and that should get you the closest hit depth. So we can use that and be like, well, we've hit this thing, but like, its furthest away point is... Oh, sorry, its closest point... Yeah, its closest point is further away than our closest hit. So we don't have to bother going down there. Right, it's interesting. What else? Yeah, I wanted to fix this ray direction. So we've got a ray direction. Like, it's a direction, it's a normal. Well, I've just gone and scaled it like a silly person, right? So it needs to be multiplied by the sine of that. So we just, mirror it basically and keep it normalized. So I don't think there's anything else that we... Yeah, we just rotate directions and... Yeah, fix it down here as well in the past. Right, so I think that's... Oh yeah, the closest hit depth. So now our closest hit depth, we get a hit. If the hit is less than... Well, it's greater than 0, so it's not behind us. And if hit.t is less than closest hit depth, and voila. Spaghetti code. Okay. That's cool. You know what spaghetti code is? Right, so interestingly enough... Oh no, we might need to... we might have to scale the ray actually. Because it's not doing those things now. Right. Yeah, so we do actually need to scale it rather than doing that. But we'll need to renormalize it, I think. Right. So Cool. So I think that would have, that must have fixed something. Not sure what though. Still looks alright, that's good. Believable. What about those reflections? Yeah, those reflections are good. Yep. They're believable. Cool, so where's the optimization? Well, when you're here, it's still kind of 3 ms. Are we... Right, it's not really going around the back. Hmm. Yes, I would say that it's not... I don't know. Maybe it's definitely not ray tracing against stuff that's... Yeah, I think we have to have more... Yeah, I think maybe it might be beneficial in the future to go back to like a binary tree. Maybe. For a few reasons, maybe. Because if we go back to a binary tree, we could be like, which one's the closest? And then literally just like go down that direction. And if we find a hit, all of the stuff behind it could just be cancelled. So we don't even have to bother. Yeah, we don't even have to bother looking at the stuff behind it at all. Because right now, it all depends on the order of the tree. If this one is the first one in the tree, the first sibling, then, well, you'll be searching through all of this first and then through all that. So, yeah, there's something to note down. I want to whack a to-do label somewhere. Somewhere a bit obvious. Oh, Vim used to do that. Right, to do. Maybe we should switch back to a binary tree, as it would be easier. As it would be easier to simply select the closest child node that was hit and go down that tree first. Thus populating... Oh, wait, I forgot one more thing. Thus populating this earlier. Or with a nearer result earlier, and avoid traversing further back parts of the tree. That's a big old waste. So that'll be core optimization. I think that'd probably be a lot of big wins in the future. So there'll be less tree traversal. One thing is we don't actually reset this local variable when we get our closest hit in the local space. So there will be savings that we're missing out on currently. So that means that we set it here. hit... Oh, we don't even have a hit t. Let's recalculate hit t. Length of... length of... in local space. And what is the ray origin in... and I guess local space. Not the local space of the object. Yeah, that's right. So that'll be updated better. Let's quickly test that out, see if we see any tangible improvement. We only saw one side though, and again, we don't... So... Right, that is actually a bit quicker, because at this viewing angle we was getting 3 ms here, but now we're again 2.5 ms. So we did actually get some savings there, but we won't get savings if we go around this side, because it probably is searching that side of the tree first. Or maybe. No, but you get all the savings from the siblings. No, all of these... Sorry, all the... in the local space of the object, that's the thing we just changed. So maybe. Maybe. Yeah, there would have been savings overall. Okay, that's good. How else can we improve this? So, there's a big one that's sticking right out. So when we've got debug stuff in here, we can remove that for a second. So let me just show you how much better it is when we remove the debugging stuff. So that's just debug drawing some outline ellipsoids for the tree and that. This is some like invalid traversal stuff. Like, we could probably get rid of some of that. It's pretty safe right now. So if we remove it, yeah, I wonder how much of it. Let's measure that separately. So let's go back to. Hang on a minute. Hang on a minute. Oh, I've already got a thing around there. Right. So we just disabled the debug drawing if statements. So let's go around here. The outlines. I think that's basically where we were before. We're getting 3 milliseconds now. Why is it slower? Well, we don't know actually where we were, isn't it? Because there was the outline thing. Yes, hard to know where we were exactly. Yeah, not gonna lie. Right, so let's put it here. That's about 6 ms. Doing that. Well, again, it's really hard to know. Yeah, again, up right close is about 6 ms. I guess we can try that. There's a bunch of if statements with some printing. So why don't we comment these ones out, or maybe we just yeah, why don't we comment all these boys and girls out. And just see, like, with these print statements and checks all the time, is that impacting the performance, or how much does that impact the performance? It'd just be good to see that, really. That check's done once at the end of the frame. We're not really fussed about that one. So at the end of the shader. After just in the ray tracing. Is this one having the measurable performance? So I think it does. It goes from about 6 to 5 ms, I think. There's this sort of stuff, this draw thing that shouldn't be in there. That doesn't need to be in here anymore. We can delete that. But yeah, we're definitely going to re-enable these things though, because these are going to be a big help for catching bugs and not crashing the GPU. So we'll keep those on. So what's the next sort of biggest issue with this shader? Well, so if you know how GPUs work, you've got a compute unit, you have multiple compute units. The GPU is made up of a bunch of compute units. Each compute unit has a little it has a vector operation unit, a scalar, arithmetic unit, and then it has maybe some caches for memory, like all your VGPRs in there or your SGPRs in here or whatever. So this compute unit runs 32 threads, or it has 32 wide SIMD unit, which is 32 threads, and it executes the same line of code across all of those, across all those lanes in the VGPR. Some of those lanes can be inactive, so it might choose to do a multiply instruction, but the mask, the active mask, will say, but there's only like 4 lanes of the multiply which are active, so we won't do anything on the rest of them. So where this inactiveness comes from is if statements. So it runs it all in lockstep for 32 threads, so that's 32 pixels. So when you have an if statement and a branch, if all threads go down one if statement, there's not a problem. But it's when they go into different if statements, how does the GPU handle that problem? Well, it executes all of the if statements that have at least one active lane in it. So, looking at the code, do we see a problem? Here we've got one branch is quite small, right? I've commented out the code here, which, right? This one here is quite small as well, right? Just put something on and adds an integer. So if it executes both sides of these if statements, ain't too bad. Obviously there's a thing in here. Oh, we didn't test removing that, did we? Okay, anyway. Yeah, it's a debug thing. That would really go in a release version or whatever, but anyway. This bottom level one. Here you have bottom level leaf, which is an ellipsoid that we actually render. It does all of these multipliers and adds, and a square root as well for that length. It then says, hey, if there is a hit, do all of this shading. What does all this shading mean? Well, look at this guy here. Does a bunch of more maths. Right. Samples from a cube map. Does some more sampling from a reflected radiance map. It also goes over every single light in the scene, which we only have 2 right now, and then calculates the radiance for that light, which does a bunch of more maths. Maths all the way. So basically this is expensive. And we're doing it with a bunch of inactive lanes in, with a potential amount of inactive lanes, because some threads might be looking at top level leaf, some threads might be looking at a parent, but some might be looking at a bottom level leaf, or some might not even be hitting any of, wait, Yeah, some might be inactive just because the ray completely missed, right? So there's tons of stuff here that can make the lanes inactive. So what we need to do is we need to take all of this out and put it at the end. So for now we'll just do a closest hit, but in the future we might want to do transparency. And in that case, we'll make the shader more expensive and build up a list of things and then process them later. Maths. Yeah. Maths. Not math as well. Good old classic English maths. Yeah, mathematics. Quick maths. Yeah, there's no quick maths for me. The quick maths for me is getting out the calculator and doing like 8 times 9. And I'm like, whoa. Yeah, I never trust my brain with maths. I'm always like, right, get out the calculator, because I didn't really practice enough with it. So yeah, I'm never trust. Obviously, like with nine times table, I could do that. 10, 5, 2. I probably do threes and 4. I think like there's sometimes tables where I just wouldn't. I think it's when I go like over 10. I think that's when my brain's like, no, get out the calculator. Yeah, you never know. 1 plus 1 could be could be wrong. There's people out there trying to change it, you know. Yeah, branches, man. So when you hit this, we basically just want to add it to an array. But how do you know if it's the closest hit? Well, we could calculate this way earlier. So we only need that. So with this, we can get everything, the rest. Well, no, we don't, because we need the hit normal. Yes, you do a closest hit position and normal. Maybe put it into view space. I don't know. So if closest hit depth is less than if closest hit depth, well, so this is where you don't need to do a length op. So that's another bit of savings, right? So I could do a bit of a square at the end. Yeah, big savings then, actually. Oh, you need to be... That might be okay. Yeah, that's okay. It's squared. Still kind of squared, but it's so... Oh, I think you do a length there. You know what? Screw the optimizations. Let's not do them. It's okay right now. So we're still carrying with this optimization, obviously. So that's less than... right, just realize that needs to be its own one. That's hit t local space. So if hit t Wrong way around. Then we obviously just yank that line. We assign it there like that. And then I think we want to take all of this. Yeah, no, I read that. That's cool. So I think we just need to take, because we're not going to have any of these rotations in that already. So I think if we get the closest hit, still going to have some inactive lanes, but it's a bugger. Also, we're doing multiple shadings as well. With this current one, if we hit something that's further away and then closer, we're going to do the multiple shadings per pixel, which gets expensive. So there's that savings too. And even with the optimization where we pick the closest node, I think there's still a chance where that could happen. So regardless, it's better to do this. So then after you get the closest... Oh, I did that the wrong way around. Yeah. So I want to get the closest hit normal. Wait. Yep. So I need some more registers to be allocated, damn it. Closest hit pause. Closest hit normal. So this can be uninitialized because this will be our check. So here we'll just set them. Closest hit pause view world space. Very, very terrible thing. And then position normal. The hit T doesn't need to be calculated. That was only for what reason? For checking closest, right. Good, but okay. So now we just need to take this. So this is saying if there wasn't a closest hit. So then the shader, we also have a else statement we can do. And we can actually just take all of this here, this shading thing. And we can go ahead and fill that in like so. So this can all go here. So we've reduced the complexity down by a whole lot. It doesn't look like a lot, but remember that function is huge. It does a lot of stuff. So this does far less now. So that's good. Maybe we can reduce it down even more in the future. There's a bunch of these length operations. Wait, that one can go now, isn't it? Yeah, there's that length op. We can hopefully get rid of that and maybe do some other things too. But yeah, good for now. Shoot, we didn't update the we need the closest hit depth in. Yeah, we need that. Closest hit depth in view all space. Hit view. Okay. So we should probably move that down to here as well. Cool. So taking a look at the end of the shader, we get the view direction Yep, that doesn't change. This will then be closest hit position, followed by closest hit position. And then we do our shading, and that's the final color. Boom. All right. So in future, if we want to do transparency in this ray tracing, we'll have a list of things that we process here. But we'll see about that when we try and add that feature. I don't want it yet. But it's something we can add when we do more rendering stuff in the future. So here it is with the optimization. It seems to still be working right. We've got the stretched, rotated object. The light seems to be bouncing around okay. If you follow this blue light, it's going to the sort of right-hand side and the left-hand side, right? So we seems to be okay. That's good. So let's see about the optimizations, how well it's doing. So right, it was something like that. Was about, it was 6 ms initially. Well, that's about 5 ms. Now it's about 4. If we get this close, it's about 5 ms. That's cool. So we've definitely got some savings. Yeah, it definitely got some savings, but this is only with like 2 instances. Should we go ahead and make more instances? Yeah, I wonder what else we can do. Yeah, I wonder what else we can end up doing. Let's go ahead and put more instances down. Let's make like a grid and see what we're gonna do there. So with this BVH instance, we might keep the spinny one. I could just do a for loop over a range. So we had 16, for instance, maybe. Oh. Dim times dim. For range y0 dim. For range x0 dim. Then maybe we won't keep the stretchy one. We can maybe just rotate all of them. But yeah, so we'll just say like, I could do, if I did x take dim divided by 2. Yeah, then if you make it 5, then it'll be split evenly. Something like that. So then this other one here will be z. Take dim divided by z take dim divided by 2. So that'll be centered. We can put the rotation on all of them. It'll be a bit of fun. To see that. So we're doing 25 instances now. Right. And then we build it. So fingers crossed that works. Here we go. Sorry. It's the y-axis. Right, if the stream dies, I'll be right back, but it should be fine. Out of bounds access. Why is there an out of bounds access? What is that in again? What shade is that in? Uh-oh. 0, 0, 0. Right, base node index. Start plus. So this is why I kept this stuff in, obviously, because reasons like this. But yeah, so I think these are invalid data, some of these. So when we print back from the GPU, we fill up the buffer. Right, here we go. So this one's quite high. How do we get a number that big? Right. Is that the allocator? Making that? That would be good to know. Right, the base node index might be a... No, it's way too bloody high. Yeah, we've got to see this separated. Right, I've got more information now, so let's see that. Hopefully it doesn't just crash. That BVH base node index is high. How did it get to that? It shouldn't be any more than... No. Right, yeah, so it would be up to 16 and then... Right, so if I take 60... Out loud. Yeah, I would take 64k. Then I shift it further by... How is it 6? Right. What's the number when you unpack it? Wait, instance node index. Oh no, it's not even that, is it? Hmm. So I think I might be grabbing the wrong node or something. You know, we can check if we say like, you know, don't hit. Yeah, if you disable this, disable the top level leaf so we never go into the instances, and then if we always hit the always hit the bottom level leaves, this should render something horrible. Oh, this is some cool new effect. Yeah, so my normals are now wrong. You'd have to then make them... You would then have to set this one to hit pause, local space. If that was to view correctly. All right. Maybe not then. Ooh. Yeah, because that'll be done in... Yeah, the ray direction will be off. That'll have to be a local space one. Yeah. Right, there's no easy way of doing that anymore. But you saw that we were ray tracing against it, and it wasn't erroring. So my feeling is that the problem is coming from when it does get the BVH instance, for some reason, it's setting the wrong base node index here. So the top level instance is fine, because we weren't getting any errors when it was ray tracing against it here, right? All seems okay. So it's when it hits the bottom level one, something is wrong. Yeah. So let's scale. The thing we can do is scale back the. The thing we can do is scale back the number of nodes. We can just say, hey, just do 3 by 3. What happens there? And I can't see a thing. Uh. Hmm. You expect to see something here? Not that way, this way. Don't see anything. What about a 2 by 2? We was doing 2 before, isn't it? So it might not be doing it. Right, I don't see anything. What about 1? So if 1's not working, that is even more bizarre. Oh yeah, we can't do 1, isn't it? Damn it. Right, so we can't do 1, so let me duplicate this. I've not got support for a 1 node tree because I do silly stuff. Yeah, I did another leaf. Oh my days. Guys. I don't know if you can see the problem, but I sure can. I'm not even putting elements into the array, I'm just like, you know, just call the function and it'll be fine. What a melon. Y times dim plus x. Because, there we go, now we're actually putting stuff in the instances array. Man, I can't believe that the GPU lived with that. Right, here we go, 25. Awesome. Yeah, who needs water? 25 instances. There's my water shader. That's all you need. Bunch of rotating spheres. Or squished spheres. Looks a bit weird in some cases, though they'll have to be offset a bit, but done. Yeah, so if you could see the performance, it is a bit noisy. The scene is kind of very dynamic. You know, I've disabled the debug visualization stuff, but it's hard to really tell what it is, but it definitely stays below 10 for a lot of it and then goes up to about 10. This is where it starts to go, it's about 12 ms at peak. So if we fill the screen with instances, it's probably going to be quite... It might be a problem. But if we... You know, that's only 2 milliseconds there. So this is how many spheres is this? They're kind of overlapping as well. We are going to get overlap. Yeah, what sort of so we've got 25. What's going on in the tile? 8. So 64, 8 times 8 times 25. That's the number of ellipsoids that we got. 1,600. So we do a full screen of the 1,600. That's the we're going about 10 to 12 ms at worst. So I guess we can quickly look to see if there's any other low-hanging fruit. Something else we could try and do is switch to that binary tree thing. I reckon that would be a big gain for overlapping things. Maybe. Yeah, for overlapping things would be a big gain, but you've still got the problem with the traversal. So we've probably got a lot of low VGPRs. I don't know, is AMD got that? AMD shader debugger Linux. They've got one. Well, there's a few ones, right? There's a shader debugger. There's a new one. I think this is the new one. The Perf Studio. Because I can see like we'll see more actual information about how the shader Linux. Cool. Can I get it? I got a tar file. What we got? Right. Extract here. So there's like a server thing. I don't know what that's about. What's this sort of Steam thing mean? Right, so start 64-bit Steam apps. Right, so you run the server. In the back. This is very Linuxy. See, in Windows you'll get like a proper app. Like, what's going on? Running the application. The second component is the plugin. In the application's address space or graphics API calls falls into the server. But where's my UI? Yeah, I don't get what it's going to do. Like, is it going to launch another application alongside it? They've got like 2 images. I don't know what I just downloaded. Right, so this you can run it on Linux and then it's got to report to the Windows client. Okay. Well, we have another one, I think. Profiler. I forget AMD makes processors. Right. I think I got this before, wasn't it? Yeah, I got this one before, and then I realized that the light theme. It thought the dark theme was like a light theme. Yeah, they. It was weird. So the text and the background were the same color. So lovely. But yeah, I've already downloaded one of these before, as you can tell. So let's see if this one's any better. So this should hopefully give us some good information on like how many registers are allocated on our shader, and maybe we should kind of try and reduce those, because the more registers that you allocate in a shader, the less times it can switch between. So say if there's per compute unit, there's like 1,000 VGPRs. If you use, yeah, say you've got like 1,000 VGPRs, and your shader invocation uses 256 VGPRs, which is the most, I think, before it spills. It really depends on the hardware, right? You can, when you get to a memory access that you gotta wait on, the shader, the compute unit can switch to another shader because it just stores the other it stores the other instruction pointers. So it's pretty cool. So obviously the more of them, the more of shaders it can switch between, the less stalling you're going to get. So if you lower the VGPRs, you'll be able to have more shader invocations. So if you have 128 VGPR allocations, that's 8 shaders you can run. It can switch between 8 shaders when it reaches a memory access and try and run more code, which is quite cool. Just run this guy, see what we get. Right, I clicked on it, it did nothing. There's probably a single application. RGP do I run? I'm just trying to run all of these. Oh, we got something. What did I do? Analyzer. Thank you. Well, I guess I get. I've done lots of research in this stuff, so, and I kind of do it as a full-time day job now. I've been doing it for like 3 years, so it's just stuff I picked up on. Like graphics programming is this really weird niche. What? I think they fixed the theme. This is legit. It's still white though. I didn't know what do we do here, can I? Can you open like a process or something? Like what the crap is going on here? Oh, it is. Compute Poland state object files. Oh, this sucks. How do you get them? Because, well, this ain't useful. I want the low level details. I don't want. That's kind of crap. See, I want that GPU profiler, I think. Radeon. GPU profiler. CU data. LDD. Hang on a minute. Right, it's saying that it can't find it. Is that because it's not looking in its own local directory? Is it in here? Lib ice. There it is right there. So can I do something fun? Like, I don't know, taking all of that and pasting it here. No. Oh, you bugger. So I've got to like somehow tell it where to look. You bugger. Well, I forget these things. There's like an LD. Can you do like an R path, isn't it, or something? No. No. LD preload. So yeah, maybe I do. Right, LD library path. So the LD library path. Yeah, so I think I can do something like this. Equal ./lib, right? Take that. Man, I can't believe they didn't link they've not set the R path in their exe, and they make me do that. Anyway, it runs. I can open a profile. Great. Well, this is a useless application unless we have a profile. We can find a way to get that maybe, but what else is available to us? So I think maybe you meant to run these applications in something else, because documentation. Yeah, how do I generate a profile? Developer panel. Oh, right. Yeah, but how do I generate a profile? Oh. At the developer panel, read more on the documentation here. Is it that developer panel app? Developer panel. Right. Capture. Available features. Profiling. Offline. I just want to know the number of VGPRs in my damn shader. Why is things so damn complicated? Capture target. Applications. Game. Connection. Connect. AMD Spear V. What's this block list thing? This looks bananas. Do I just run, like, there must be other Vulkan applications running already, so I would expect. Capture target. Well, what do I do? Do I run my game now? This is bananas. I expect these guys to just be able to, like, intercept anything because they like have the driver code or whatever. I don't know. Well, that did nothing. Right. I have to read documentation or some crap. Initial setup. You press connect, right? I did that. Next. Right, you gotta put in some IP address of what? I don't know why we need the internet. I just want to. Also connect any application. Block list. Right, so you block applications which have. Where's the preset button? Oh, there's the start shell script. I don't see no start shell script anywhere. Or is it that in the error message? Oh, I can't see that. Huh? Oh, the setup script in the scripts folder. Right, I did just click past that. Oh, I've got to damn mod it as well. A plus X. Right, super secret password. Done. Yeah, see that. So, does it say I have to reboot as well? Like. Well, let's check what it did. I just trusted AMD running some at root. Silly me. Right, so they do stuff with the kernel things, which I have no idea what that does. Set up permissions and stuff. Right. Back to there. Right, so that worked. I guess I could do local host. So the next thing is they had like these profiles or whatever. I didn't know what that was. Alright, what do the docs say? After connection made, go to capture tab. Available features. Presets. I don't see this preset thing anywhere. Um, right, so are these like load preset profiling? I see. Application filters. Any application, Vulkan basically. Right, so when I run it, right, what else? So profiling. So they've got this like sample.exe that they've put in. They just wrote a name. I just wrote game in there. So if I do something like run the game, do we see anything show up? Status offline. Do I have to do anything with my game? I think it's just called game. Um, so memory trace. I'm confused. Where did? I can't even do this capture target. Vulkan connection thing. It doesn't even show up. Anything show up. Do I have to do a certain feature in the Vulkan API or something? Like, is there a certain extension I have to use? Or does it come built in? It's just bizarre. Capture tab. The applications panel, a list of applications you previously or currently connected to. Or existing applications. See, I think I got that server thing set up wrong still. You can run it on the system and start a driver connection as a filter against a client application. See, I think was it? It's that key in it. System monitor. Might just crash the system monitor. Don't we have a game in here somewhere? Yeah, it's just called game. Like, I got the right process name. I didn't really say anything about process name. Only applications with entries specified in the application list that match the selected API filter will connect. Yeah, I think I'm missing something key here. I don't know. Make note of your system's IP address in the command prompt ipconfig. Yeah, localhost should have been alright. Well, there's the loopback address, isn't it? It's one. Yeah, maybe we try that one. Well, there is local, isn't it? Man, these things. It appears to be there. Yeah, I'm missing something clearly. This is just explaining the UI. Radeon. Yeah, not set to run in program, man. Hmm. But yeah. Okay, that was interesting trying to set that up. I was hoping it would work right away, but it hasn't. So, yeah, I think I would want to try and optimize this a little bit more because, well, we were able to do 1600 nodes at 16, less than 16 ms, so maybe it's fine. Maybe it's okay. What's that perf again? Yeah, it's about 12 ms there. I would hope. So either I've got a choice of doing an optimization that'll hopefully make it better, or because I want to make it. Yeah, I'll have a think about it. Maybe we spend next stream doing more optimizations. I definitely need to do another video though for YouTube to catch up. So maybe next stream we'll spend more time optimizing this. I'll see, or maybe we just do a video and we just get on to planning out what are the next things we want to do, because we'll just be putting a pin in the rendering stuff for a while and doing an editor where we can make models and things and getting the other parts of the engine together. But yeah, I don't think there's anything that really sticks out. That could be really, other than switching to that binary tree. I can't reduce the number of VGPRs here because I need that instance index in there. Maybe there's a thing I can think about. I don't think this can get optimized really when we switch from a top level to a bottom level node. We've done the closest hit optimization. Also, my ellipsoids are kind of big as well, which doesn't help. The tree, the code that makes the ellipsoid tree isn't the best. Could be made better. I wonder what happens if we turn off, if we just do simple shading, right? Oh, I've hit something. Let's just make it red. Like, I wonder how much of an impact the shading is actually having. Let's make it red. Yes, it's still kind of like, it dances around from like 4 ms to 12 ms. I maybe have something. Maybe it's only 3 ms there. Let's turn the shading back on. Maybe there's something to investigate when it comes to the GPU system. Maybe we've got. It could just be OBS running, but I don't think it is OBS running. But yeah, this is all like PBR shaded stuff. It's dancing from 4 ms sometimes to 12 ms. Whereas if I come back to here, it stays at a pretty stable 5 ms. So why is one of the frames 4 when closer? It doesn't make any sense, right? So like how can we have a stable solid? There might be some data race happening there, maybe. I don't know. Because that doesn't make any sense, right? I have a slower time with more pixels. Yeah. Cool. Well, I'll put a pin in it there today. Next stream we'll work on maybe more optimizations, or we might just make a new video for YouTube explaining what we've got. So doing a nice recap, and then making a to-do list for what are we doing next regarding the editor and the road to the editor. So I'll post links. So for those who have source code access who support the channel via Twitch or Ko-Fi, I'll be uploading that after when the stream closes there. Also there's the YouTube channel and a VOD channel if you're going to catch up on past streams. I'll next be on Sunday 6 p.m. GMT plus 1, and then Tuesday and Thursday 4 hours ago. Right. Thank you all for coming, everyone. I hope you have a good start to your weekend. I'm going to go ahead and eat food, exercise, go to bed, something like that. Something like that. Hotco reloading. Here we go. He said go dot though. By CC. So you'll get a raid. No worries. Thank you, Pete. It's good to meet you, iPin. Pennies. And all in the mage. Heart you too. Thank you guys. Have a good start to your weekend. Bye bye.